Hi everyone. Today let's look at the LeetCode problem 1161, maximum level sum of a binary tree. Given the root of a binary tree, the level of its root is 1. So we are considering this root level to be 1 here for this problem. The level of its children is 2. Okay, so here the children 7 and 0 will have level 2. Return the smallest level x such that the sum of all the values of the nodes at level x is maximal. So if you take this example, so let's just take the sum of the nodes at each level. So here it's 1, here it's 7, here it's 7 minus 8, so it's 1. So as you can see, level 2 will have the maximum sum. As you can see in this question, you have to return the smallest level. So assume that level 2 and level 3 had the same sum, then we have to return level 2. Now let's see how to solve this problem. If you see here, this is a classic level order traversal. So all that we need to do is a breadth first search. Maybe you can solve it via depth first search also, but I would go with the breadth first search. All that you need to do is keep track of the level and also the maximum sum and the level at which you found the maximum sum. That's all we need to do. Now let's just code this up. So we'll just go for the level order traversal to start with. So that will be Q. Okay, we will just push the root element to start. Okay. So to track these data points, we will have maybe a max level, which we'll initially set to 0. So it'll be like because our current levels start from 1 onwards. Then we will also keep track of our levels, and we will also have one variable to keep track of our max sum. I'll just put it as max level sum. Yeah, to be more precise. Keep these variables together. Okay, so these are our tracking variables. Okay, now while not q.empty, so this is our normal level order traversal with some minor modification to keep track of the sum. So I'll just increment the levels because levels start at 1. I will also have one variable to keep track of the current level sum. Okay, now while sorry, my bad. Here we'll just take this queue size because we just want to iterate through the current level alone. So this queue size will help me to iterate through the current level. Okay, there are multiple ways. I am doing this way. I less than queue size. Okay, plus I. All right. Now let's see, right? We will have to now track the current level sum. So that will be tree node star. So we'll take out the front of the queue. Okay, and we'll just pop it also to current level sum. I'll just add this into the queue dot. Into the current level sum. Then if there is a curl left, then I'll just push it to the queue. And if there is a current right, I'll push it to the queue. So I believe now you understand why I've just iterated through the queue size only, because these elements should go into the next level. So just this will ensure that we only iterate this for loop until the current level size. Okay, now next will be if max level sum, okay, is I think I can just reduce the size a little bit. Yeah, is less than current level sum, then we can just set max level sum to be equal to cur level sum, and we will set the max level, I think that was the variable, yeah, is equal to the current level, okay, which we track using this variable. Okay, this should be good enough. Let's see, return max level. Okay, this looks good. Okay, I think, yeah, there's something that I'm missing. Let's just check that up. Okay. Oh, this was expecting 3. Let's see. Use this case. So I should have given -100. Oh, okay, I understand. So the reason is that all are negative, so I'll just keep this as int min. Okay. Okay, so that looks good. The time complexity will be order of n, because we have to visit all the elements, and space complexity will be also order of n, because if a worst case, if I have a full tree, I can have n by 2 elements, n by 2 leaf elements, so at the lowest level. So that means I could have a space complexity of order of n, where the queue is filled by n by 2 elements. So that's it for today. Thank you. Have a good one.